Well, we're continuing on our 200 drawing prompts book, and today we're up to prompt 138, which is solar system. And here's our solar system drawing. I suggest you turn the video off now that you've seen the drawing, and don't watch the rest of the video, because I talk way too much. Well, today's prompt is solar system, and I guess they're talking about the solar system we live in. The problem with drawing a solar system, you never see it drawn to scale, because I don't think you can in any practical way. Because if you make the sun the correct size, everything becomes a dot. And then the distances involved are amazing. There's the four inner planets, called the four rocky planets, there's Earth right there, and it's one astronomical unit from the sun. The Earth's average distance to the sun, they just calculated that as an astronomical unit. So the four inner planets are Mercury, which is so close to the sun you can only see it at sunrise and sunset with specialized equipment. Venus is about the same size as the Earth, about 75% or 80% the size of the Earth, but it's covered in clouds and you can't really see anything. Then there's the Earth, the third rock from the sun. And then the fourth one is Mars. It's 1.5 AU from the sun. And it's, we don't realize it. We're always talking about Mars. Mars is pretty small. It's only about, 53% of the size of the Earth, and much less dense. And then at 2.2 astronomical units is the asteroid belt, which includes several dwarf planets like Sirius. And then we jump out to 5.2 AU, which is Jupiter. This is where we start the gas giants. And then we go out to about 10 AU is the famous Saturn with its rings. But we have another ring planet, which is Uranus, and it's about 19.2 AU. And then for a long time, that was all the planets they knew about. But then technology got better, and they found Neptune, which is 30 astronomical units. You see how these distances are getting much bigger? And then they found Pluto, which they've declassified as a planet for many reasons. It hasn't, one of the main ones is it hasn't soaked up all the material in its orbit. And it's almost 40 AU away. So you're never going to see a drawing of the solar system for real, because it kind of looks like this. The sun with dots. But there's more. And the more is the fact that the sun, right there, is in orbit around the center of the Milky Way at about 500,000 miles per hour. 500,000 miles per hour. So it's moving. And so the planets, here you can see Mercury and Venus, the Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, they're actually spiraling through space following the sun. Now, this is a ridiculous, deal, because we don't do it this way. You got to pick a frame of reference. So for the normal orbits, we just put the sun as stationary and make that the frame of reference, and then make the orbits on the plane of the ecliptic, they call it. But then it even gets stranger, because the Milky Way itself, if this is the Milky Way, it's moving at an astonishing 1.3 million miles per hour through various factors. It's being drawn towards the Andromeda Galaxy, also the Great Attractor, and the expanding universe. So the Milky Way itself is moving 1.3 million miles per hour. And so you think, well, gee whiz, how many laps does the sun make around the Milky Way at 500,000 miles per hour? Well, the sun takes 250 million years to make one lap around the Milky Way. So when you see those simple drawings of our solar system, it's not so simple. Not only that, there are asteroid belts. There are several, I don't know the exact number, but several dwarf planets. And there are also numerous moons. I think about 50 moons that orbit the various planets, except for Mercury and Venus, which has no moons. All right, so let's get started drawing on our simplistic drawing. And of course, that's the reason you never see a real drawing a scale drawing of the solar system, because it's just too complicated. Even if you understand it, it's complicated. Not that I'm qualified to understand it, but well, you already saw how this picture looks. I haven't, because I'm just making it up. But we'll just draw the planets in order. That was Mercury. This would be Venus. And behind Venus would be the Earth. And it is just a little bit bigger than Venus. Now we got Mars, which is considerably smaller than the Earth. It's only 53% the size. And its mass is only 10%. So that's Mars. Now the biggest of the gas giants. There's 4 gas giants. First one is Jupiter. And then the famous Saturn. Make it a little bit smaller. We're running out of room, aren't we? That'd be Saturn. And we'll call this Uranus. Uranus. And the last one will be Neptune. And just for the heck of it, we'll put Pluto in here. Pluto's real tiny, so we'll just make it small. And let's just go crazy and put the Earth's moon in here too. Okay, you know, sadly, the deal is that the only thing that, well, I guess Mars was famous for having, when you look through a blurry telescope, it looks like it has canals. Venus is covered in clouds. Mercury is small, doesn't have many markings. Jupiter has the stripes and the big storm. Put that in there. You know, I've looked through telescopes, as just about everybody has, and when you look at the planets, you're almost disappointed because everything is so blurry. We'll do the rings of Saturn. Of course, Saturn has many more rings than one. It has actually thousands. What they do is they kind of clear one another out. A ring will sort of soak up everything in its path. So there's distinction between the rings. When you look at Saturn through a telescope, you really only see one ring. I mean, unless you're looking through, a real powerful telescope. On a clear day, you can see, a clear night, if you've got a good set of binoculars, you can actually just about see the rings. These are the rings of Uranus. Uranus in the wrong place. It's a famous big red spot. Jupiter is the biggest planet by far. Sometimes known as a failed star. Okay, this is Mars, so let's put some terrain on Mars. And now we're down to the Earth. Since I'm a North American, let's put North America. The problem with that, when I put North America here, that means you got the Pacific Ocean here, and there's nothing there. And here's the moon. Hey, this is Saturn. I'm not Saturn, what am I saying? This is Venus. Venus is really covered in white clouds, but we're gonna cheat a little bit and see and pretend like we can see the ground underneath. And this is Mercury. It's actually closer to the sun. It's only about half an AU, less than half an AU from the sun. But since it doesn't have since it's so small, it doesn't have very much of an atmosphere, and so it doesn't have any clouds to hold heat in. So Venus is actually hotter than Mercury. Now the Earth is in kind of arbitrarily defined as the habitable zone, and that's the zone where water isn't frozen all the time. The average temperature of the Earth is around 57 degrees, I think. So that keeps water in liquid form. Now Mars has water. Jupiter is way too big, it's just crushing, and some of the moons of Jupiter have a lot of water. Same with Saturn. Uranus and Neptune, they're frozen with some water, and Pluto is also frozen, of course. It's 40 AUs out. Okay, let's sink this thing in. Okay, this is our dwarf planet. Pluto. This is Neptune. I mean, these planets are, these gas giants are so far out, these last three anyway. Well, Jupiter's pretty far out too, but it's actually generating some heat and has a magnetic field. These gas giants here are so far out that everything freezes, even methane freezes. Now some of the moons I believe there's over 40 different moons in the solar system. Saturn has the most. Jupiter has the moons that are most likely to harbor life. It's only 9.5 AU from the sun, so we get some sunlight, but the gravitational drag of Jupiter actually causes some plate tectonics in its moons, so they have a little bit more heat than some of the other moons, and a lot of, they believe, a little bit more liquid water. A couple of, at least one has a liquid water ocean that's covered in ice, and one of the hypotheses is that that could harbor life. Of course, it'd be microscopic, but you got to remember, for the first three and a half or 4 billion years of the Earth's history, life was nothing but microscopic. I'm in the rare earth. I'm in the rare earth camp when it comes to civilizations other than human. I think the conditions for life are probably probable, but the conditions necessary to raise up a civilization of intelligence, as we humans define it, is probably very rare, and we're probably the only civilization in our galaxy. You know, we were talking about how far away the stars are. The other galaxies are even further. But anyway, for a civilization to arise, you've got to lots of things have to happen. You got to have a planet in the habitable zone of the star, unless there's some kind of chemistry that we don't know about, because you have to then the planet has to have a magnetic field to call the magnetosphere that blocks the radiation from the sun. And then it has to be, the the planet has to be stable for billions of years, and there's no indication that's really all that common. You can't get hit by asteroids and have stars blowing up. Well, you got to have a star like the sun. Our sun is what you call a yellow dwarf, has a long, stable majority. In other words, it's alive for a long time. And that's necessary when you consider that the Earth, for most of Earth's existence, life sprung up pretty quick. I don't know exactly how, but it did. But it was only in the last 750 million years was that life anything more than pond scum. It's all single cell. And then you never see this argument, but this is my own personal argument, and that is, you have to, for a civilization to grow up, you need a power source. You need coal, petroleum, something that's really energy intense for the sentient beings to raise up industry with. Well, to have coal and oil and hydrocarbons, you got to have plate tectonics. The ground has to fold up and kind of smash together organic material, which has to rot and stack up over millions and millions and millions of years until it's converted into raw hydrocarbons, so that the humans, or the aliens, or whoever needs it, can build steam engines and ultimately rockets. So you heard that argument here. No one ever talks about that one. But we wouldn't have a civilization right now if it wasn't for coal, oil, and so forth. And if we wouldn't have And if we didn't have the coal to build the industry, we would never have rockets. Another thing we've got to have in the rare earth deal is we've got to have oxygen. And the only reason we have oxygen, 21% in the atmosphere, is because those cyanobacteria 3 billion years ago produced oxygen as a waste product. As a matter of fact, at one point in our history, Earth's history, there was percentage of oxygen was very high in the atmosphere. The atmosphere was actually a little bit denser. Which accounts for, you've probably seen the pictures of the large fossil insects and so forth that are very, very large. Well, you can't have real large insects with 21% oxygen. You got to have a lot more, 30, 40%, because they don't have lungs. They have to soak up the oxygen through their, they have air tubes and stuff in their abdomens. And you just can't do that with 21% oxygen. So all this stuff has to happen for there to be a civilization. And the planet has to be stable enough, has to avoid, being hit by another planet or a large asteroid or a large comet or the star blowing up. And then there are the fact that within a few hundred years of technical advancement, whatever civilization is going to discover a nuclear fission. And when you discover nuclear fission, that means that you have the means to destroy yourself, as we've discovered. Okay, let's start coloring these planets in. Okay, this is Pluto. I'll just make Pluto kind of ice colored here. Neptune. Make these two icy planets. Make them blue. Now Saturn kind of has some, color, a little bit more striations in its coloring, so. When you look at Saturn through a telescope, a small telescope anyway, it just looks like you can see the rings, but everything's just kind of white. And of course the rings around Uranus, you can't even see with a civilian telescope, because you can't even see the planet so far away. This looks like a little star, if you can even find it. Okay, now let's do the rings of, or the striations on Jupiter. It's the red spot. I'm going to color it in with brown at first, and I'll change it. Now I come to Mars. Now we got Earth. From this distance, I don't know if you can see much green, but we'll put a little green in the eastern U.S., the Yucatan Peninsula, Cuba, Bahamas, Hawaii, and we'll fill in the ocean, Pacific Ocean here. Pacific Ocean is it's really big. If you get a globe and look at it, you can turn the globe side around to the Pacific Ocean, and if you just look at the Pacific Ocean, it takes up your whole field of view. The Earth is, I think, about 70% covered by water. Maybe a little bit more. Now the land area on Earth, now that Mars is much smaller, but the land area on Mars, since it doesn't have any liquid oceans or anything, is about the same as the land area on the Earth. There's a little known fact for you. Okay, now we've got Venus, which is covered in clouds, but we're going to pretend like we can see the surface. I mean, most places on Venus are so hot you could melt lead. They call it a runaway greenhouse effect. And Mercury. Venus is the morning and evening star. If you look where the sun's rising in your location to the east, in the east, look kind of over to the right and up a little bit, you'll see a bright star right at sunrise, if it's in its right place in the orbit, and that will be Venus. It's very bright. Now if you look at it in a telescope, you won't see anything. It just looks like a big star. Same thing with in the evening, as the sun's going down. Probably see it. Okay, now we have, let's make the moon kind of this gold color. Okay, so let's label our planets. This is Mercury. Venus. The Earth's moon. Earth. Mars. Jupiter. Okay, this is 138, I think. And today's date is 21st, Thursday, December 21st. First day of winter. Okay, that's it for Memphis drawing on this December 1st day of winter. We drew the solar system. Tomorrow, the prompt is fireflies, so that'll be another hard one. So get excited, and I hope we'll see you tomorrow.